Hey Yahoos, I'm again on paternity leave. I'll be back soon, I promise. They can't keep me away. Anyway, yesterday we were checking out binomial expansion, and today we're looking at factoring expressions, which is kind of like going the other way. So at the top of your notes, you can put 6.3 factoring and try these as a warm-up. They're sort of what we did yesterday. Cool? Pause me and try that. Go. I swear I'm not paused anymore. So let's try this guy out. I bet they're hiding under here. There we go. You distributed 3 into both of these, and you ended up with 12x plus 3. You distributed this into both of these, and you ended up with 10x minus 4x squared, and we distributed into this. And this one you had to be a little bit careful with because you have this negative sign. So this gets distributed. This is like a negative times a positive, so therefore it becomes negative. And this is a negative times a negative, and so therefore it becomes positive. Watch your signs. All right. So today I want you to be able to factor expressions by removing common terms. So yesterday we were looking at expansion, and today we're looking at factoring. They're opposites, right? They're inverse operations. They're not really inverse operations, but they're working backwards. So yesterday we did this. We said, ooh, that's too bold. Yesterday we said this. We said I have 3 of these, and so we distributed these in. Great, fine. Today we're going the opposite way, because we're saying, okay, let's take this, let's make a nice factored form. Let's change its form. And we're going backwards. We're saying, hey, look, there's a 3 in this, and if we look at this with nerd goggles on, this is 4 times 3. So there's a 3 in 12 also. We pull the 3 out and leave what's left over. We'll go over that a lot slower, but that's what we're doing. They're both useful in different ways, right? We want to be able to go both ways, because sometimes, maybe you have maybe this is useful sometimes because you have blah plus 2, and you can add these like terms. Or maybe you have all of maybe you have all of this divided by 6, and then it's nice to have a common term out here, because then you can cancel these out and go over 2, right? So this is like we're working with changing the how these look to make them more useful. So factoring really is undistribution, if you like. It's pulling out a common term of 2 or more monomials, and it's useful in simplifying. And I think it's really satisfying and fun. So here's sort of a list of how to do it step by step if you like a list. But basically, this is still the same idea from previously. You find a greatest common factor. You say, hey, look, the factors of 12x are 3 times 4 times x, and the factors of 3 are 3 times 1, I suppose, and their greatest common factor is 3, right? Ka-ching, we found the greatest common factor, right? And so if you divide by the greatest common factor, if you take 12x and divide by the greatest common factor 3, the 3's cancel out, and what you're left with is 4x, right? And here, if you divide by 3, you're left with, you go divided by 3. If you divide by 3, you're left with 1. And what we're really doing is pulling a 3 outside. We're pulling that greatest common factor outside, and then saying, hey, what's left over on the inside is 4x. It's whatever's left over after we've divided that out. And what's left over here? 1, right? And there should be that same plus sign in the middle. And so this is the factored form, right? Ka-ching, ka-ching. What's nice about this is you never have to guess if you've done it right. Just distribute in to see if you get this 12x plus 3 back. Like this, they should be the same. We shouldn't have changed anything. So let's try it out. Right? If you go 3 times 4x, that's 3 times 3, that's 12x. Got the plus sign. And 3 times 1, 3. And hey, look, it's exactly back to where we started. We don't want to change anything. We don't want to change the essence of the expression. We just want to change how it looks. Right? So great. There we go. All right. So here, try it yourself. Factor this guy. Give me a pause, and I'll try it for you. Okay. Make this a little smaller for you. So I'm going to do this the sort of long and slow way. I know that 15y is 3 times 5 times y. And I know that 20 is, among other things, 4 times 5. Right? So that's what the that we found. We're looking for the greatest common factor. Looks to me like the greatest common factor is 5. It's sort of the only common factor. So I'm going to divide by 5 and divide by 5. What we're really doing is pulling a 5 out of each of the terms, right? So if we pull a 5 out of 15y, sort of like saying divide by 5, what we're left with is 3y. And if we pull a 5 out of the 20, what we're dividing by 5, we're left with 4. And so this really turns into the greatest common factor that got pulled outside. There was 5s involved, right? And left inside is what's left in here once we pulled a 5 out of there, a 3 and a y. And what's left in here is this 4, right? Plus 4. This plus is this plus. So this is its factored form. And if we're not sure, we can check. 5 times 3y, yeah, 15y. And 5 times 4, yeah, 20. Notice that although there are two terms, we're really pulling, there's not 2 5s out in front. Yeah? There's only 1 5 right here. Because as you distribute, it goes into both terms, and so it shows up twice. You do not need to write it twice. The math will just handle it for you. Because when you distribute this in, you go once, twice, and so the 5 pops back into existence twice. In the factored form, it's sort of simplified, depending on what you need. So you only need to write it once out here. You don't pull it out twice. Yeah. Okay, so let's give it a shot. I guess this is what we just did. So this one is straightforward. I'd like you to try 3 and 4, see how you do, and I'll jump in and factor them with you in a second. Yeah? Go. All right. So with this mess here, let's just let you see if you got them right or not. Ka-ching, ka-ching. So there we go. Let's get this out of the way because we already did that one. And let's look at example 3. If you got them, move on. Be quiet, Mr. G. Fast forward. Don't you wish you could do that in real life? All right. I see that this is really 7 times 2 and an x and an x and a y. Yeah, that's in this one. And in this one, we really have 7 times 3 and an x. And so what they have in common is a 7 and an x, a 7 and an x. So we're going to put our parentheses up, put our plus sign in, and pull out all of the common factors. I'm going to pull a 7 and an x out of both of these, right? 7x. So I'm going to maybe just can't cross them off, if you like. And then what's left inside is the 2x and y for this one. 2x, y. And what's left here is the 3. And so this is the factored form. If you're not sure, distribute back into check. The numbers, the coefficients, excuse me, give you 14. That gives you x squared, and there's your y, so this part's good, ka-ching, and 7x times 3 is 27x, ka-ching. Great. This guy, we can do the same thing. You can call this, this has a 4 and an a square, an a and an a and a b and a b. This piece has 4 and a 4 and an a and an a and a b. And this one has a 4 and a 5 and an a and a b and a b. Right? If you think about what a squared is, it's just a times a, and b squared is b times b. So the common pieces, the greatest common factor, is A, they all have a 4. They all have, oh, there's 4 and a 4 and a 4. They all have at least one A. So there's an A and an A and an A. And they all have at least one B. A B and a B and a B. So let's pull that out front. 4AB. Yeah? And what's left on the inside in this term is AB. There it is. And what's left on the inside in this term is a 4 and an A. And let's get a different color in here. What's left on the inside in this term is a 5 and a B. And there it is. Life's more fun with sound effects. Great. So now you can factor. Yeah? All of the other little nuances apply, like negatives, right? My blood type is B negative. Get it? So try the same thing with negatives, and let's get the cat out of the way so it doesn't get in our face. If we were to distribute, going back the other way to like yesterday, if we were to distribute this negative in here, you'd go -3 times this and -3 times that, and you'd end up with negative times each of them, and you'll notice that it flips the signs of both. This was positive, now they're both negative, right? So if we started with something a little different, if we were working backwards, right, now we're starting with this, you'll notice that both of them have a negative number, sort of like saying -3 times -5, right? And so you can undistribute that. You can factor it, undistribute, right? And pull this -3 out because you notice that they both have negatives. Cool? So take that idea and try one of these three, well, try 2 of these 3. This one's easy, this one's a little harder, this one's a little harder. Actually, B and C are about the same. Give them a shot, and I'll pop back on in a second, and we'll try it out together. Go. All right, so this is just like the example we did last. I know that this has, if you really wanted to, you could factor the -1 out first, but this is like saying -1 times 3 times 4 times x. Right? 3 times 4 gives you 12, -1 gives you -12, and the x is there. And this is like saying -1 times 4 times 5. Not bad. Okay, so I know that we're going to have some parentheses. Let's see what we can pull out that's common. Hey, look, they both have a -1. They both have a 4. So let's pull those out. We're basically dividing by those. We're going to pull those out and see what's left. If we pulled out -1 times -4, out front comes, sorry, -1 times 4 gives you -4. And what's left on the inside is a 3 and an x and a 5. The hiccup is we pulled this negative out. So this, you see this as a +5, put it in as a +5. Because as you distribute this in again, you get -4 times 3 gives you -12x, which is what we're looking for. Ka-ching! And This, since it's a positive, -4 times +5 gives you -20, which is what we want, right? That's what we're looking for right there. If we made a hiccup and put in erroneously a negative right there, then once we distribute this -4 in, it would be -4 times -5, and you'd have +20, which is not what we want. Quack. So it's got to be -4 times 3x plus 5, the negative and the negative distribute in. Cool? All right. So let's try this next piece. Same sort of idea. You don't have to do this factor tree every time. I think when you're starting out, it helps. Oh, we're missing a bracket here. I guess, well, I'm going to put a bracket in there anyway. 27 is what, 9 and 3? Yeah. And y. And 4, sitting out here, 4 is 2 and 2. Can't be factored. Maybe I messed up the numbers. Oh, yep, backwards. Pay no attention to that one. Sorry, this one can't be factored as is. Right, I was working backwards and botched it. This one should be okay though, so let's try that one. So 42 is 6 and 7, and y squared is y and y. And 30 is what, 6 and 5, and x and y. So what do they have in common? Well, a 6 and a y. Hey, this one has 6 and a y also. So out in front of my parentheses, we're going to put a 6 and a y. And inside the parentheses, we're going to leave all of the stuff that was left over, 7 and y, 7y. And 5 and x. 5 and x. Cool. And this was positive, staying positive. This is negative. I guess we'll leave a negative. Cool? Great. So, take that idea, try a bunch of these. It's just factoring, pulling things out. Look at the solutions and look at how they'll sometimes they will pull out a negative, sometimes they won't. Just look at how those negatives interact as you pull them out. Once you're done, try these BDK, L, and O from number 2 from this chunk down here. Sort of challenge problems. They're not necessarily extensions, but if you can see how those are being pulled out, you can factor out packets of things, and that's all that's going on in here. Cool?